Students, in this video, we're going to go over some fission versus fusion. So both of these processes are nuclear reactions, and they happen when we're involving just the nucleus of the atom. Now, when we're talking about fission and fusion, there is a lot of energy associated with these two processes, and that was one of the key differences that we talked about in that first video when we were talking about nuclear reactions versus chemical reactions. Now, just to give you an idea of the amount of energy that's released during these kinds of processes, when we're talking about 1 kilogram of uranium, for example, versus coal, the amount of energy that's released from just 1 kilogram of uranium is equal to the amount of energy that's released by 4 billion kilograms of coal. Think about that difference, 1 kilogram versus 4 billion kilograms. The same amount of energy is produced from both of those two processes. So we can get a lot more energy out of those nuclear reactions. Excuse me. So the first process we're going to talk about is fission. Now, fission is going to involve one large nucleus. So we're going to start with one large nucleus, and then it's going to split. And so that one large nucleus is going to split into two smaller nuclei. And you can see when that happens that there's also these neutrons that are being given off as well. So the atomic numbers down here at the bottom, when you add those two atomic numbers together of those two new nuclei, those atomic numbers added together will equal the atomic number of the larger nucleus that split. And when you look at the mass numbers, those mass numbers don't exactly equal the mass number of that larger nucleus until you factor in the amount of neutrons that are also being given off. Okay, so these big, large nuclei split when a neutron hits that large nucleus. And so the unbalance between the protons and the neutrons in that nucleus cause that nucleus to become unstable. And that unstable nucleus is then going to split into those two smaller nuclei. And as you can see, it gives off a lot of energy, which says it's why it's used to generate power. So there are nuclear power plants dedicated to fission, not necessarily for that other process that we're going to talk about in a minute. Now, here's the thing with fission. Fission can undergo what we call a chain reaction, because when you have a neutron that hits this nucleus and this nucleus becomes unstable, that nucleus is going to split and it's going to give off additional neutrons. Now, here's the thing. When you have a sample of something, like in this case, uranium, you don't have just one atom of uranium in that container or that vessel, whatever you're talking about. You have lots and lots and lots of atoms of uranium. And so those neutrons that are being given off by that one fission reaction are going to go and they're going to hit nearby uranium atoms. They're going to make those nuclei become unstable, and those nuclei are going to split. So it's just going to be an ongoing process where you have a nuclei that splits. Those neutrons being given off are going to hit nearby nuclei, causing them to split, and so on and so forth. This links to a video that goes more in depth into fission reactions and chain reactions. And I cannot show it in my Zoom and then upload it to YouTube because of copyright violations. So you can access this video by looking at the PowerPoint in Schoology. So this is what I was talking about with the chain reactions. And now in order for the chain reaction to occur, the nucleus has to have enough mass. So just because you have a whole bunch of uranium atoms in that same container doesn't mean that all of those uranium atoms have the same mass because of isotopes. So they do have to have the right mass. It's called the critical mass that is going to be able to keep that chain reaction going. Then let's talk about fusion. So fusion is where you have something small that comes together to make something large, fusing. Okay, so we're starting with two smaller nuclei that come together to make a larger nucleus. And this is actually the process that powers the sun. So in the sun, you have two smaller hydrogen atoms, those two hydrogen atoms are going to come together and they're going to make a helium atom. And it does give off a lot of energy. We know that the sun has an enormous amount of energy associated with it. Now, the fusion reactions, we don't have any nuclear power plants dedicated to fusion because those fusion reactions are, there's just a lot of energy to contain with fusion reactions. So this video here, oops, excuse me, this link here links again to a video about nuclear fusion, and you can take a look at it by going on to YouTube or going into Schoology on the PowerPoint, clicking on this link. You can watch the video. I just couldn't share it here because of the copyright violations when I try to upload my video into YouTube. So feel free to take a look at that on your own time. If you have any questions about fission versus fusion, just let me know. Thanks.